All right, welcome to our review on how to use Venn diagrams. And we're going to start just by representing categorical statements. The categorical statements that we've got, we have an A statement here, all dogs are mammals, an E statement here, no dogs are mammals, an I statement, some dogs are mammals, and an O statement, some dogs are not mammals. And what we'll do to start out is just show how we're going to represent each of those in the Venn diagram itself. So let's start with one. All dogs are mammals. So let's say we've got two groups, dogs, mammals. This circle, let's look at the spaces. Number 1 represent all dogs that are not also mammals. Space 2 represent everything that's both a dog and a mammal. And space 3 represents things that are mammals that are not dogs. So when we want to say that all dogs are mammals, what we're saying is that there is no dog that's not a mammal. At least that's visually how we're going to represent this on the Venn diagram. So we're going to say that there are no dogs in this area. And that's what our shading means in the Venn diagram. It means this area is empty. That's what we're saying. There's nothing that is a dog that is not also a mammal. So that's how we're going to represent these A statements. All right, let's erase all that fun stuff. What did I do? Not that. Well, I want the eraser. Okay, so we're going to erase this. We can keep dogs and mammals because that's still true. Okay. So now we want to represent no dogs are mammals. Again, think about what these spaces represent. To say that no dogs are mammals, again, we know that's false. We know that all dogs are mammals, but we're just thinking about how to represent this. To say that no dogs are mammals is to say there is nothing that is both a dog and a mammal. We're saying that this space is empty. There's nothing here. They're only dogs and they're only mammals, but there are no things that are dogs and mammals. So that's how we represent E statements. Down out of here. All right, moving on to I statements. Some dogs are mammals. Again, thinking about the spaces. To say that some dogs are mammals, where some here always just means at least one. At least one. And so what we're saying when we say some dogs are mammals, there's at least one thing right here. There is one thing that is both a dog and a mammal, and we're going to represent that with the X. I'm going to take these out just so we see how that's represented. I'll put that, and we'll just go put the X right there. And then lastly, we're going to look at E statements. I'm sorry, O statements down here. Right. Some dogs are not mammals. And the order here is really, really important. What this is saying is that there's at least one thing that exists that is a dog, but is not at the same time a mammal. And that's represented by there being at least one thing in one. Because what did one represent? Again, the space of one represents things that are dogs that are not also mammals. So that's where our X is, and I'll erase all this extraneous stuff so you just see that's where we would put it. Just like that. So that's how we do just simple categorical statements. So I'm trying to get to the next slide here. What's going on? Here we go. Oh dear. Okay. So, no human is omniscient. Something is both divine and human. So at least one divine being is not omniscient. And one thing you'll see is that this argument here is not a standard categorical syllogism. The first thing that we need to do in order to do the Venn diagram for a categorical syllogism is put all this in standard form. So I'm going to start here because this looks to me to be the conclusion, because it's got this conclusion indicator word. So at least one divine being is not omniscient. So 3, some divine beings are not omniscient. Okay. Now here's what I want to do. I'm going to look at, that's my minor term, that's my major term. So I want to make sure that 2 includes the minor term, which is divine beings. So that's going to be this statement: something is both divine and human. Again, thinking about that in our system, it means at least one thing is both divine and human. So we would write some divine things are human. And human now, that is our middle term. And we should see omniscient up in our major term. No human is omniscient. No humans are omniscient. And you might wonder, why did I use the word are instead of is? Because in our system, everything is no are. Some are. Some are not. All are. So we just put it in standard form. So now that we've got it, our syllogism in standard form, we can begin to fill out our Venn diagram. So the way that we do this is, again, we've got a universal statement and a particular statement. Always start with the universal. The universal will rule out what you can do with the particular statement. So we'll start by putting in our diagram, no humans are omniscient. Oh, first we need to label things. This is the minor term, divine beings. This is the minor term over here, omniscient. And this is the middle term, humans. Very good. So first we're going to diagram no humans are omniscient. What does that mean? It means everything that's a human, represented by this circle, is not also overlapping the circle for things that are omniscient. This is empty. There are no humans that are both omniscient, or there are no things that are both omniscient and human. Now, when we were some divine things are human. So there's at least being. There's at least one divine being. So we're over here. We're like looking at divine beings. There's at least one divine being that is also human. So area 4 is where divine beings and human overlap, because this area right here is already empty. So what we're going to do is we're going to put an X in area 4. And first I'm going to erase. Oops. I didn't mean to erase everything. What? What did I do? Did I erase everything? Well, it's all right. We'll diagram it again. Divine being, omniscient, and human. So again, no humans are omniscient. At least one divine being is human. Some divine things are human. And now let's look at the conclusion. Some divine beings are not omniscient. And here's what we do. Once we get to the conclusion, we're just looking to see, is the conclusion already in this diagram? And the answer for this one is yes. How do I know? Because here's at least one divine being. that is not omniscient. It's not inside the circle of things that are omniscient, but it is inside the circle of things that are divine. So this argument is valid. All right. All right, so let's do one more together. Only wars are great evils. Some wars are ordained by God. Hence, at least some great evil is ordained by God. Let's start with the conclusion, which again looks to be this. Hence, at least one great evil. Oh, we went backwards. Go forward. Okay. Just go forward. Goodness. Okay. So we're going to start with 3. Okay, this is driving me bananas now. Can I get to the eraser? Nope, cannot. Well, this will be good. No, there it goes anyway. Okay. Okay, just that's driving me bananas. Okay, so what it looks. Some evil is ordained by God. That's this sentence. Some wars are ordained by God. Well, that's the major term, so that needs to be in 1. So let's start here. Only wars are great evils. Remember, this should be all. I'll just shorten it to evils. Are wars. It is not all wars. That's incorrect. It's all evils are wars. All great evils are wars. And then, okay. Let's just do it before we lose it again. All right. I think is it something my finger's doing? It should all be locked. So I don't know. So let's start with all evils, or let's see. Evil, ordained, and war. So all evils are wars. So what does that mean? It means everything that's evil is also a war. Here we go. Some wars are ordained by God. And so we're looking at war and things that are ordained by God. And that is ambiguous between 5 and 6. Both 5 and 6 are wars that are ordained by God. And in those sorts of cases, we just put the X right on the line. And I'm not going to try to erase that because who knows what's going to happen. But the X is right there on the line. And whenever an X is on the line, you know right away that the argument is simply invalid. And let's leave it at that.